Imagine a massive wave, 1,000 feet tall, rushing toward the west coast of the United States. To put that in perspective, that's taller than the tallest buildings in many cities. This kind of wave is called a mega tsunami, and it's far beyond the size of any normal tsunami we've ever seen. While normal tsunamis caused by earthquakes or underwater landslides are often under 100 feet tall when they hit land, a 1,000-foot wave is on a whole different level. So what would happen if something this huge struck the Pacific coast? First, it's important to know that a wave this size would likely be caused by a massive underwater landslide or a super violent volcanic eruption near the coast. It wouldn't be like the usual earthquakes that caused tsunamis, but more like a sudden collapse of a giant chunk of the ocean floor, pushing an enormous amount of water upward and toward the shore. The energy released would be unimaginably powerful. As the wave approaches the coast, it would move incredibly fast, traveling many miles per hour, much faster than a person can run. Unlike regular ocean waves that you can see rolling gently toward the beach, a mega tsunami is more like a wall of water. It would rise up suddenly, flooding the coastline with massive force. Cities along the coast like Los Angeles, San Francisco, Seattle, and Portland would be in the direct path facing total destruction. The wave would destroy everything in its way: buildings, roads, bridges, and homes, sweeping away cars, boats, and even large ships. Because it's so tall, the water would reach far inland, flooding many miles from the coast. The shape of the land would affect how far it spreads, but low-lying areas could be completely underwater. The damage to infrastructure would be catastrophic, cutting off power, water, and communications for weeks or months. Emergency services would be overwhelmed immediately. The initial impact would cause a huge loss of life, especially in crowded urban areas without enough warning time. Even with modern technology and early warning systems, a wave this large would give very little time for people to evacuate safely. Coastal towns and cities would face a disaster on a scale never seen before in American history. As the wave moves inland, it would carry a massive amount of debris, including trees, vehicles, and parts of buildings, turning everything into deadly projectiles. The destruction wouldn't be just from the water, but also from the force of all this debris crashing into structures and people. After the first rush, there would likely be smaller waves following, continuing to cause damage and flooding. Overall, a 1,000-foot wave hitting the west coast would be a nightmare scenario. The sheer force, speed, and height of the water would overwhelm everything in its path. But this is just the beginning. What happens after the wave hits? The long-term effects on the environment, people, and cities would be just as devastating. After the initial wave crashes onto the shore, the damage would only start to reveal itself more clearly. The immediate flooding would begin to recede, but what's left behind would be a landscape completely transformed. Roads and highways along the coast would be washed away or buried under mud and debris. Bridges might be twisted or broken, making travel and rescue efforts nearly impossible in many places. Ports and harbors, which are vital for trade and supplies, would likely be destroyed or severely damaged, cutting off crucial access for ships. The water from such a massive wave would carry a huge amount of sediment, salt, and debris far inland. This would poison freshwater sources like rivers, lakes, and underground aquifers. Farms and fields would be covered in salt water and mud, making the soil unusable for growing crops for a long time. The loss of food production would add to the already overwhelming challenges faced by survivors. In the weeks following the wave, thousands of people would be displaced, forced to live in emergency shelters or makeshift camps. Cities would struggle to provide basic needs such as clean water, food, and medical care. Hospitals and clinics close to the coast might be damaged or overwhelmed with injured people, creating a healthcare crisis. Power grids already knocked out by the flood would take months to repair, leaving millions without electricity through harsh weather conditions. Environmental damage would also be severe. Coastal ecosystems, including wetlands, beaches, and forests, would be destroyed or severely altered. Many animal species would lose their habitats or die in the disaster. The salty floodwaters could kill freshwater fish and other aquatic life. Toxic chemicals and oil from damaged factories, storage tanks, and vehicles could leak into the environment, causing pollution and long-term health hazards for people and wildlife. Beyond the physical destruction, the psychological impact would be enormous. Communities shattered by loss of family, friends, homes, and jobs would face years of recovery. Mental health issues like trauma, anxiety, and depression would rise sharply. Governments and organizations would need to provide not only physical rebuilding but emotional support to help people cope with what they experienced. The economic damage would be staggering. Coastal cities contribute billions of dollars to the national economy every year through business, tourism, and industry. The destruction of infrastructure and property, combined with the loss of productivity, could lead to a recession or even a depression in the affected regions. Insurance companies would face huge claims, and rebuilding costs could run into hundreds of billions of dollars, if not more. So while the wave itself might last only minutes, as it crashes ashore, the aftermath would last years or even decades. The ripple effects would be felt not just on the West Coast, but across the entire country as communities try to recover and rebuild from this unprecedented disaster. One of the biggest challenges after a 1,000-foot tsunami hits the West Coast would be dealing with the long-term environmental and climate effects. When such a massive amount of seawater floods inland, it doesn't just vanish quickly. Saltwater can linger in the soil and groundwater for months or even years, making it very hard to restore farms and natural vegetation. This would cause food shortages and threaten the livelihoods of many people who depend on farming and fishing. The ocean itself would also change in the days and weeks after the wave. The force of the tsunami would stir up the ocean floor, lifting sediment and possibly toxic substances like heavy metals and chemicals trapped in the seabed. This pollution could harm marine life far from the coast, disrupting entire ecosystems. Coral reefs, fish populations, and marine mammals would face serious threats, affecting both biodiversity and fishing industries that communities rely on for food and income. In addition to environmental damage, the social and economic effects would keep spreading. Many small towns and communities along the coast would lose homes and businesses. Some might never fully recover or could even disappear if people move away to safer areas. This kind of disaster could cause a large shift in population, with many people relocating inland or to other states, changing the social fabric of the region. The government and emergency agencies would also face huge pressure. Rescue and relief operations would have to cover a massive area with millions of people affected. Roads and airports could be damaged, making it harder to get supplies and help to those in need. Coordinating efforts between federal, state, and local levels would be critical but very complicated. Planning for future disasters would likely change a lot after this event, with more focus on early warning systems and evacuation plans. On a broader scale, the global economy might feel some effects too. The west coast of the United States is home to major ports like Los Angeles, Seattle, and Portland. These ports handle a large part of the country's imports and exports. If they are damaged or closed for a long time, supply chains could be disrupted, causing shortages and price increases on goods across the United States and even worldwide. One final, often overlooked consequence would be the cultural and historical losses. Coastal cities have many important landmarks, museums, and heritage sites. Many of these could be damaged or lost forever. Preserving memories and history in the face of such a disaster would be a tough challenge for communities trying to rebuild their identity and spirit. The long road to recovery would not just be about fixing buildings and roads, but also about restoring hope and normal life for millions of people affected by a tsunami of this size. Looking further ahead, the rebuilding process after a 1,000-foot tsunami would take years, maybe even decades. Communities would need to rethink how they build near the coast to avoid the same kind of destruction in the future. That could mean stricter building codes, creating buffer zones with natural barriers like wetlands, and investing in better early warning systems to give people more time to evacuate. Urban planners and engineers would have to work together to design cities that can withstand or avoid the worst damage from future tsunamis. Insurance companies would also face huge challenges. With damage on this scale, many might struggle to pay out claims, and some people could find it difficult to get insurance for coastal properties afterward. This would affect the housing market and could change where people decide to live long term. Mental health would be another major concern. Surviving such a catastrophic event would leave many people with trauma, grief, and anxiety. Support systems, including counseling, community programs, and mental health services, would be crucial in helping survivors rebuild their lives emotionally as well as physically. In the bigger picture, this kind of disaster would likely change how the world thinks about natural risks. Governments and scientists might push for more international cooperation on monitoring earthquakes, volcanic activity, and ocean conditions that can lead to giant tsunamis. Investing in global early warning networks could save countless lives in the future. Schools and communities would also likely include more education about natural disasters and survival skills. Knowing what to do when a tsunami warning sounds could make a huge difference in saving lives. Drills, clear evacuation routes, and Public awareness campaigns would become standard in coastal areas. Despite all the destruction and hardship, history shows that people often come together after disasters like this. Neighbors help neighbors, volunteers arrive from other states, and communities work hard to recover and rebuild stronger than before. Technology and science would also play a big role in improving disaster response and recovery efforts. In the end, while the damage from a 1,000-foot tsunami hitting the West Coast would be unimaginable, the response and resilience of people could inspire hope. Preparing for such a rare but powerful event is essential to protect lives and reduce the impact when nature shows its greatest force. Imagine waking up tomorrow to a world where every electronic device suddenly goes dark. No lights, no phones, no internet. What if a massive solar flare, also called a coronal mass ejection, hit Earth and wiped out all electronics and power in an instant? This isn't just a minor blackout. It's a total shutdown of the systems that run our lives, and it could happen in just minutes. Right when the solar flare hits, it sends an intense burst of charged particles racing toward Earth at nearly 1,000,000 miles per hour. These particles slam into our planet's magnetic field, creating a powerful geomagnetic storm. Within just minutes, the electric currents induced by this storm would overload transformers and power grids across entire continents. Cities from New York to London, Tokyo to Sao Paulo could lose power almost instantly. At the exact moment of impact, satellites orbiting Earth would be hit hard too. Many would fail or go offline, cutting off GPS, weather monitoring, and communications. In the first few minutes after the flare, airplanes in flight would lose navigation systems, forcing pilots to rely on manual control. Traffic lights would stop working, causing immediate chaos on roads. Emergency services would find their radios dead or severely disrupted. Within half an hour, entire regions could be plunged into darkness as power plants trip offline to protect themselves from damage. The electronic pulses would fry unprotected devices, making phones, computers, and cars that rely on electronics stop functioning. The sun itself might appear eerie in the sky, as intense solar storms often cause vivid auroras seen much farther from the poles than usual. Red, green, and purple lights glowing ominously. Meanwhile, power grids scrambling to respond could experience cascading failures, where one damaged transformer leads to the failure of others, widening the blackout. In the first hour, large parts of North America and Europe could be completely without power, and this blackout might stretch to other parts of the world as the storm's effects ripple globally. By the end of the day, the impact would be undeniable. Hospitals would be struggling to power life-saving machines on backup generators that can only last a limited time. Water treatment plants without electricity would stop working, risking contamination of drinking water. Refrigerated food would begin to spoil. The massive scale of destruction to electronic infrastructure would mark the start of a disaster unlike anything modern society has faced. A true humanity-ending scenario if recovery takes too long or fails to happen. This is just the beginning of what a massive solar flare hitting Earth tomorrow would look like. As the hours pass after the massive solar flare hits, the true scale of the disruption becomes clearer. Without power, cities quickly descend into chaos. Traffic jams form as stoplights fail, and public transportation grinds to a halt. People trapped in elevators or subways face dangerous situations with no immediate way out. The communication networks are mostly dead. No calls, no texts, no internet. Cutting off families and emergency responders from each other. In the first 6 hours, hospitals and emergency centers rely heavily on backup generators, but these only have fuel for a limited time, usually a few days at best. Without electricity, many medical devices, including ventilators and diagnostic machines, begin to fail, putting lives at serious risk. Food stores close as refrigeration fails, and soon panic buying spreads in areas where power remains on, but most places already face empty shelves. The timing of this disaster makes it even worse. If it hits during winter, heating systems stop working, leaving millions vulnerable to freezing temperatures. In warmer climates, air conditioning failures cause heat waves inside homes and buildings, which can be deadly for the elderly and sick. Water supply systems suffer too, as electric pumps stop working, causing shortages of clean drinking water and sanitation problems that could lead to disease outbreaks. Governments and utility companies scramble to assess the damage, but the geomagnetic storm has fried transformers and electrical components over thousands of miles. Replacing these parts is slow and difficult because many are custom built and can take months or even years to manufacture and install. International aid is complicated by the fact that many countries are affected at once, limiting the ability to help one another. By the end of the first day, it's clear that this isn't just a temporary blackout, it's a massive breakdown of modern infrastructure. Millions of people are stuck without power, clean water, or communication, and the emergency services are stretched beyond their limits. The disaster is unfolding fast, and the world faces the terrifying reality of a long, uncertain recovery ahead. As the second day after the massive solar flare unfolds, the damage to society deepens. With power grids crippled, many cities remain in total darkness, causing widespread fear and confusion. Without streetlights or traffic signals, accidents on roads increase sharply, and emergency responders struggle to reach those in urgent need. The blackout affects airports and railways, grounding flights and trains, which isolates communities even further. Many people begin to realize that this won't be a quick fix. Gas stations can't pump fuel without electricity, so vehicles become useless, making transportation a huge challenge. Grocery stores, addresses that manage to keep some supplies quickly run out, and with no refrigeration, food spoils rapidly, increasing the risk of hunger and food shortages in urban areas. People start rationing what little they have, but without restocking, supplies dwindle fast. Communication remains almost completely down. Without cell towers or internet, people rely on battery-powered radios or emergency broadcasts if available. Social media, emails, and phone calls all gone, cut off personal and official communication. This lack of information fuels rumors and panic in some regions. Governments work to send out emergency messages through satellite channels, but coverage is limited. Water scarcity worsens as electric pumps remain offline. Many households run out of drinking water, and public fountains or wells are overwhelmed with demand. In some places, the lack of clean water causes hygiene problems, which raises fears of disease outbreaks. Hospitals struggle even more as their fuel reserves deplete and backup generators fail to support all critical systems. Power companies begin prioritizing repairs on essential services like hospitals, water treatment plants, and emergency centers. But replacing the fried transformers and damaged infrastructure is a massive challenge. Some areas may be without power for weeks or months. Meanwhile, communities try to adapt by using candles, wood stoves, or hand-powered devices, but life becomes a struggle without modern conveniences. By the end of day 2, the full scale of the disaster's impact on daily life is undeniable. Society is pushed to its limits as people face uncertainty, shortages, and isolation. The path to recovery looks long and difficult, and the world braces for what comes next. As the crisis moves into its third and fourth weeks, the reality of a world without reliable electricity sinks in deeply. With most major cities still powerless, daily life is forced to adapt in ways no one expected. People begin to rebuild routines using old-school methods, manual tools, printed books, and face-to-face communication replace the digital conveniences that once ruled. Markets reopen, but mostly with basic goods, and bartering becomes common as money loses some of its usual power without digital systems. Medical care faces a critical test. Hospitals struggle to treat patients without modern equipment, relying heavily on limited supplies and the dedication of healthcare workers. Vaccination programs stall, and minor injuries risk becoming deadly due to lack of proper sterilization. Many people turn to home remedies and community healers, while emergency aid tries to reach the most vulnerable through trucks and makeshift clinics. The disruption to global supply chains leads to serious shortages of fuel, food, and medicine. Governments scramble to coordinate international aid, but damaged communication networks and broken transport systems make it slow and complicated. Some rural areas surprisingly fare better by relying on local resources and small-scale farming, while big cities face greater challenges due to their dependence on imported goods and electricity. By this stage, power restoration efforts are ongoing but slow. Replacing damaged transformers and rebuilding the grid is a massive engineering challenge, requiring time, resources, and cooperation among nations. Some regions may take months or even years to regain full electricity. Meanwhile, public morale wavers, and social tensions rise as people struggle with the uncertainty and hardships. The long-term economic impact starts to emerge, with businesses closed, stock markets halted, and governments facing immense costs. But amid this devastation, communities learn resilience. People discover new ways to live with less, rebuild local support networks, and rethink their reliance on technology. While the immediate aftermath of the massive solar flare shows the fragility of our modern world, it also highlights the strength of human adaptability. In the end, this event would be a massive reset, a reminder of how much we depend on electricity and technology. The path forward would be difficult, but survival and rebuilding would be possible, though nothing would ever be quite the same again. Imagine waking up one morning and hearing that strange gas bubbles had started erupting from the Arctic Ocean. At first, it sounds like something out of a science fiction movie, but this isn't fiction, it's methane, and it's coming out fast. Scientists had warned about this for years, what they called the methane feedback loop, but now it's no longer a warning, it's happening. And if it keeps going, it could spiral so far out of control that it ends life on Earth as we know it. It all starts with rising global temperatures. Over the past few decades, the Arctic has been warming about 4 times faster than the rest of the planet. And hidden underneath the frozen ground and seabeds of the Arctic, what's called permafrost, are enormous reserves of methane gas. We're talking about billions of tons of it. Methane is way more powerful than carbon dioxide when it comes to trapping heat in the atmosphere, over 80 times more powerful in the short term. As the permafrost melts, methane that's been locked away for tens of thousands of years begins to escape. The more methane is released, the more it heats the planet. And the more the planet heats up, the more permafrost melts. That's the feedback loop. It feeds itself. There's no off switch, it just builds and builds. At first, the release might go unnoticed, just small plumes bubbling up from remote parts of Siberia and the Arctic Sea, but satellites would start to detect rising concentrations of methane in the atmosphere. Climate models would begin to shift from bad to catastrophic. Within just a few short years, global temperatures would jump by several degrees. Oceans would heat up faster than expected. Weather would start acting strange, entire seasons would shift. Some parts of the world would go straight from winter to summer, skipping spring entirely. Crops would fail, forests would dry out and catch fire. But this is only the beginning. The terrifying part is that once this chain reaction truly begins, it's impossible to stop. Even if every country on Earth stopped burning fossil fuels overnight, the feedback loop wouldn't care. It would keep going on its own. The planet would be heating itself, powered by methane escaping from deep beneath the Earth, like the planet was opening old wounds we thought were long buried. And the more that escapes, the faster things unravel. The polar regions, once frozen for millions of years, would begin releasing methane at a scale never seen before in human history. Giant craters would appear where the ground collapsed after the methane exploded out of the permafrost. People living in the far north might see pillars of fire shooting out of the earth or ocean like the planet itself was venting. This would be the turning point. Not a storm or a war, not even a virus. Just invisible gas rising into the sky, quiet, slow, and absolutely deadly. And by the time the world fully realizes what's happening, it might already be too late to stop what comes next. By the time the methane feedback loop really takes off, the climate would start changing faster than people or governments could react. Within just a few short years, temperatures would rise so quickly that entire ecosystems would begin to crash. The oceans would absorb a lot of that heat at first, but even they have a breaking point. Sea surface temperatures would climb high enough to wipe out coral reefs, disrupt fish migration, and kill off major food sources for millions of people. Coastal cities would be the first to feel the pressure. With polar ice melting at a breakneck pace, sea levels would rise faster than any predictions. Low-lying areas like Miami, New Orleans, and large parts of California's coast could be underwater within a couple decades, maybe even sooner. Salt water would start seeping into farmland, wiping out crops and contaminating drinking water. But the scariest part wouldn't be just the rising seas or the heat. It would be the massive, unstoppable weather shifts. Entire storm systems would become larger, stronger, and more unpredictable. Hurricanes in the Pacific would slam into cities that had never seen storms like that before. Inland heat waves would grow so intense that parts of places like Phoenix or Las Vegas could see outdoor conditions so hot they'd be deadly in minutes. It wouldn't be just uncomfortable, it would be unlivable. Regions that once had mild climates like Oregon or Washington would begin facing long droughts and raging wildfires year after year. California could turn into a dry wasteland, its reservoirs empty, its farmland scorched. Massive blackouts would sweep across states as the power grid struggled under the pressure of record-breaking temperatures and failing infrastructure. Fires would break out so fast and burn so hot that entire neighborhoods might be gone in hours. Across the Great Plains and into the Midwest, the situation would only get worse. With unpredictable rainfall and extreme temperature shifts, the farming heartland of America would fail. Crops like corn and wheat wouldn't be able to grow in the new conditions. Livestock would die from heat stress or disease. Grocery store shelves would empty faster than they could be restocked. Meanwhile, people would try to move away from the worst hit areas, creating waves of climate refugees within the same country. But where would they go? The north. Even places like Canada and Alaska would be dealing with their own fires, floods, and food shortages. The pressure on governments would be overwhelming. There would be no time to build new cities or plan for millions of people to relocate. The changes would be happening too fast, and still the methane would keep rising, feeding the heat, pushing the planet closer to a point where the climate itself becomes completely unstable, beyond anything we've ever known. As the methane buildup in the atmosphere keeps growing, the world's temperature would rise beyond the threshold of what most life can survive. It wouldn't just be a few places suffering, it would be nearly everywhere. Areas close to the equator would turn into literal death zones. In countries across Africa, South America, and Southeast Asia, the heat index would reach levels that the human body simply cannot handle. In some regions, just stepping outside without protection could mean heat stroke within minutes. In cities that once felt safe, the heat would get worse each summer. Major urban centers like Los Angeles, Tokyo, and Paris could face temperatures over 130 degrees Fahrenheit during prolonged heat waves. Asphalt would melt, buildings would trap heat, and nighttime wouldn't bring relief. In fact, in some places, the nights could be even more dangerous than the days. Without cooling, people would begin dying in their homes simply because the air never cooled down. At the same time, the Arctic would be completely transformed. The permafrost, frozen ground that's been locked in place for thousands of years, would thaw completely. With every inch of that frozen ground that melts, more methane and carbon dioxide would be released. Old viruses and bacteria trapped for tens of thousands of years might also escape, adding another layer of danger. This wouldn't be science fiction, it would be a real biological threat. In Antarctica, the massive ice shelves would break off and crash into the ocean. That alone would cause sea levels to rise even faster. Coastal cities around the world would go from flooded to permanently submerged. New York City's streets would vanish underwater. San Francisco's bay would stretch far inland. Entire island nations would disappear beneath the waves. The scale of change would be impossible to keep up with. Global wind and rain patterns would stop behaving like they used to. Monsoon seasons would shift or vanish altogether. Rivers like the Mississippi and the Amazon could dry up in places or flood unpredictably in others. Dust storms the size of small countries would sweep across once fertile land, stripping away the last layers of topsoil. Even forests like the Amazon would start to collapse, first from drought, then from fire, and eventually from becoming carbon emitters instead of carbon sinks. This rapid environmental breakdown would leave almost no safe place on Earth. By this point, food systems would be gone. The ocean's fish populations would collapse due to rising temperatures and acidification. Drinking water would be scarce in every region. People who survived the heat would be left with nothing to eat or drink. And yet, the worst part is that no one would be able to stop it anymore. The methane feedback loop would be fully self-sustaining. Every new release of gas would trap more heat, which would then melt more permafrost, release more gas, and so on. It would be a runaway chain reaction, one that doesn't slow down, doesn't pause, and doesn't reverse. There would be no pause button. No part of the world would be untouched. At this stage of the methane feedback disaster, survival would be nearly impossible. With each passing week, the world would grow hotter, drier, and more unstable. Regions that once had stable weather patterns would now be facing extremes on every front. Unending droughts, storms the size of entire countries, and wildfires that move too fast to outrun. The skies would look different too. Smoke from continent-wide fires would darken the atmosphere, blocking sunlight in some areas and turning day into a dim red glow. In others, the sun would beat down through a thin layer of greenhouse gases, making it feel like the entire sky was pressing down. Breathing the air would be dangerous almost everywhere, with oxygen levels dropping and toxic gases filling the air. By this point, all governments would have collapsed. There would be no systems left to manage anything. No power grids, no hospitals, no emergency services. Satellites might still orbit the Earth for a while, silently capturing images of a dying planet. But communication between surviving groups would mostly be gone. Every region would be on its own, and even then the chances of survival would be slim. The oceans, now overheated and acidic, would emit more methane from clathrates buried under the seabed. These frozen gas pockets had been stable for thousands of years, but the rising temperature of the water would shatter that stability. As the clathrates broke apart, massive methane eruptions would bubble to the surface, adding even more gas into the air and making the heat even worse. Even in the best possible shelters, life would be incredibly difficult. Underground bunkers or remote research stations, like those in Antarctica, might buy a little more time, but eventually the same patterns would reach them. Supply chains would have been gone for months. Plants wouldn't grow, animals would be long extinct, water sources would be too contaminated or too evaporated to be of use. In the end, isolation would only delay the inevitable. The final stage of the methane feedback loop wouldn't be marked by one big event. There would be no loud explosion or dramatic finish. It would be a slow, unstoppable unraveling of every system that once supported life. Humanity would fade, not all at once, but city by city, shelter by shelter, until there was no one left to witness what Earth had become. In a few centuries, the planet might cool again. The methane might eventually break down. Nature, in some new form, could reclaim what remains. But humanity would be gone. The cities, the satellites, the history, we would become another chapter in Earth's long timeline, buried under layers of heat, fire, and silence. This is the terrifying power of a runaway methane feedback loop, a slow, invisible tipping point that could erase everything without a single weapon or explosion. Just heat, just gas, just time. Let's start with the big idea itself. What if we just started throwing all of our trash into volcanoes? It sounds like something out of a cartoon or a wild science fiction movie, but it's a question people have seriously asked. On the surface, it kind of makes sense. Volcanoes are basically giant natural furnaces. When they erupt, they release heat that can reach over 2,000 degrees Fahrenheit. That's hot enough to melt rock, so it feels like they could definitely melt some of our everyday waste, right? The world has a massive trash problem. Every single year, we produce more than 2 billion tons of solid waste. A lot of that ends up in landfills, where it just sits and slowly breaks down. If it ever breaks down at all, some of it ends up in our rivers and oceans, harming wildlife and poisoning water. So the idea of a super hot volcano burning it all away might sound like a perfect solution. Just dump the trash in and let nature take care of the rest. But even before we get into the risks or the science, there are some obvious challenges. First, volcanoes aren't everywhere. In fact, most of them are located in remote or dangerous places. The idea of loading up trucks or planes full of garbage and hauling them across the country or even across the world to reach an active volcano is already a logistical nightmare, not to mention the cost and the pollution caused by moving all that trash in the first place. Then there's the problem of getting close enough to a volcano. Active volcanoes aren't exactly stable or safe. Just being near one, even when it's not erupting, comes with risks like toxic gas, sudden lava flows, earthquakes, or landslides. Most waste disposal systems today are built to be safe and manageable. Trying to throw bags of garbage into a boiling pit of lava is neither of those things. Even if we could get the trash there, how do we actually get it in? Just tossing it from a distance wouldn't work, and getting close enough could be deadly. And here's another thing to consider. Not all volcanoes are the same. Some have open lava lakes like the ones in Hawaii, but those are rare. Most volcanoes only have visible lava during or right before an eruption. So even if we picked the right volcano, there's a good chance we'd be sitting around waiting for the lava to show up. And trying to time our garbage drop with an eruption would be dangerous and probably impossible to control. So before we even touch on the science of whether or not it would work, the basic logistics already show some pretty serious roadblocks. It's an idea that gets attention because it sounds extreme and powerful, but just getting the trash to the volcano and getting it in would be an expensive, dangerous, and very unpredictable process. In the next part, we'll look more closely at what would actually happen to our trash in a volcano and whether it would even burn the way people think. Now let's imagine that somehow we did manage to get all our trash to an active volcano and safely dumped it into the lava. What would actually happen to it? Would it just melt away instantly and disappear? The answer isn't as simple as you might think. When something falls into lava, it doesn't always burn up right away. Lava is extremely hot, usually somewhere between 1,300 and 2,200 degrees Fahrenheit, but it's also thick and dense. It flows more like syrup than water. That means solid objects like metal, plastic, or large bags of trash might just sit on top of it for a while, instead of sinking or melting immediately. Some items would catch fire, sure, but others might not even fully break down. Another thing to think about is what happens to the smoke and gases released when trash burns. A lot of everyday items, especially plastics and electronics, release toxic fumes when they're set on fire. These include chemicals like dioxins, furans, and heavy metals, which are dangerous to both the environment and human health. If we started burning tons of garbage in volcanoes, we'd be pumping even more pollution into the air, except now it would be coming out of a volcanic crater. Scientists have studied volcanic gases and found that they already release carbon dioxide, sulfur dioxide, and other harmful substances during eruptions. Adding household or industrial waste into that mix could make it even worse. It could affect air quality for miles around, especially for people living near the volcano. And unlike a controlled waste incineration plant, volcanoes have no filters or scrubbers to catch the bad stuff. Everything just goes straight into the sky. There's also the question of whether all trash would even break down under those conditions. Materials like glass and certain metals require extremely high temperatures to melt. Some parts might survive the heat or only partially melt, leaving chunks of waste behind in the lava or on the volcano's surface. And that's not even counting hazardous waste, which could react unpredictably under those extreme temperatures. And then there's the simple fact that volcanoes don't erupt on command. Lava isn't always available, so unless we're lucky enough to have an open lava lake, we'd be stuck with huge piles of trash waiting for the next eruption. That could take years or even centuries. In some places, a volcano might stay quiet for hundreds of years before it erupts again. So while the heat of a volcano sounds powerful enough to destroy anything, the reality is messier. Some of the trash might burn. Some might just sit there. Some could release dangerous chemicals, and some might never melt at all. In the next part, we'll look at places where this idea has actually been studied in the real world, and what scientists found when they tried to explore it. Even though tossing trash into volcanoes sounds wild, this idea has actually been looked at in a few places around the world, not just as a fantasy, but as a serious research topic. One of the most well-known cases is in Iceland, where scientists have studied how geothermal and volcanic energy might be used to manage waste. Instead of throwing trash straight into lava, they explored ways to use the natural heat from underground volcanic systems to help break down waste in a more controlled setting. In Iceland, some research teams looked into using geothermal vents, those super hot steam pockets underground, to process organic waste like food scraps and plant material. The idea was to create a waste-to-energy system by capturing the heat and turning it into electricity, or using it directly to decompose certain types of waste. It wasn't about dumping garbage into volcanoes, but more about working with volcanic heat in a smarter and safer way. Other volcanic regions like Hawaii and parts of Italy have also looked at similar concepts, but none of these ideas involve actually feeding trash into open craters. It turns out the dangers and unknowns are just too high. For example, one concern is what happens if foreign materials like plastic or metal interact with molten rock. These things could cause unpredictable chemical reactions, including explosions, especially if certain gases are released. There's also the question of logistics. Most of the world's waste isn't produced anywhere near volcanoes. Cities like New York, Tokyo, or London produce thousands of tons of garbage every single day, but they're nowhere near active volcanoes. That means we'd have to ship massive amounts of waste across oceans or borders just to reach a volcano. And that's not only expensive, but also terrible for the environment. Transporting trash by boat or plane releases more greenhouse gases, which defeats the whole point of trying to clean things up in the first place. In addition to the cost and environmental impact, there are safety concerns too. Volcanoes are unpredictable. Some may look calm for years, then suddenly erupt without warning. The idea of setting up a waste disposal system around something so unstable doesn't exactly sound like a smart move. And even if we found a constantly active lava lake, we'd need to build roads, containers, and equipment to dump the trash without putting workers or nearby communities in danger. There's also the question of how locals and governments would feel about turning a natural wonder into a giant trash pit. Volcanoes are often sacred in certain cultures or protected as part of national parks. Turning them into dump sites wouldn't just be dangerous, it could also spark huge social and political backlash. And so while the science of using volcanic heat in a safe, controlled way might hold promise, the idea of straight up tossing garbage into active lava is way more complicated. In the final part, we'll break down what we've learned and talk about what this idea really says about our struggle with trash and how we think about solutions. Now that we've looked at the science, logistics, and real-world attempts, it's pretty clear that throwing our trash into volcanoes isn't the magic fix it might seem like at first. Still, the fact that this idea even comes up shows just how desperate people are to find new ways to handle the massive amount of waste we create every single day. What this concept really highlights is how we keep looking for big, dramatic solutions instead of dealing with the root of the problem, how much we produce and how little we reuse. Even if volcanoes could somehow burn up all our garbage, it wouldn't stop the constant stream of new waste being created. Plastic packaging, food waste, electronics, it's all still being made faster than we can deal with it. That's a deeper issue that volcanoes can't solve, and while using extreme heat from volcanoes sounds powerful, it doesn't erase the risks. Burning waste, no matter where it happens, can still release harmful gases into the air. If we're talking about plastics, chemicals, or electronics, the fumes and byproducts can be dangerous to both people and the planet. It's not just about getting rid of garbage, it's about what happens to that garbage when we do. There's also something symbolic about wanting to throw our waste into a volcano. It's like we're trying to bury the problem instead of facing it. Just dumping it out of sight doesn't make it go away. In fact, it often creates new problems, whether it's toxic emissions, transportation pollution, or environmental damage. Instead of trying to destroy our waste in the most extreme way possible, a more practical path might be reducing how much we create in the first place. Recycling, composting, reusing materials. These methods may not be flashy, but they work. And unlike volcanoes, they don't carry the risk of explosions, lava burns, or air contamination. So, while the idea of using volcanoes as giant trash incinerators might sound exciting, it's not a real solution. It's more of a reminder that we need to think smarter about how we live, what we consume, and how we take care of the earth. We already have the tools to make a difference. It just takes the will to use them. Thanks for sticking with this crazy idea. Let us know what wild solutions you've thought about when it comes to the trash problem. Imagine you're out walking on a normal day. The sky is clear, birds are chirping, everything feels just fine, but above your head, something has already gone horribly wrong. Roughly 8 minutes ago, the sun exploded, and no one on Earth knows it yet. That's because light from the sun takes about 8 minutes to reach us, so by the time we see the explosion, it has already happened. We're just living in the final peaceful moments before the nightmare begins. Once those 8 minutes are up, everything changes instantly. The moment that blinding wave of light hits our planet, it's game over. A supernova-level explosion from the sun would send out a shock wave of radiation powerful enough to destroy the ozone layer in an instant. Earth's protection against harmful ultraviolet rays, gone. Our atmosphere would be ripped apart by a storm of deadly energy. Temperatures would spike to levels we can't survive. And this isn't something that plays out over weeks or days. This happens fast. Most scientists agree that Earth would be hit with extreme heat, followed by a total blast of radiation and pressure, all within minutes of the light reaching us. That's before we even talk about what happens next, because the sun isn't just our light source. It holds the entire solar system together. Once it explodes, Earth is no longer in orbit. Gravity disappears. Our planet would be launched into space like a rogue pinball, tumbling away into darkness with no sun, no warmth, and no hope of survival. Within less than 1 hour, oceans would start to freeze from the surface down. Crops would die, power grids would fail, but that's assuming anything survives those first few minutes, and the truth is almost nothing would. The surface of Earth would be scorched. Cities would collapse, fires would spread everywhere. And once the atmosphere gets stripped away, space itself starts to crush down on us. There's no bunker deep enough to hide from this, no shield strong enough to withstand it. If the sun exploded without warning, this would be the last day for humanity, and most of us wouldn't even see it coming until it was far too late. Once those first deadly 8 minutes pass and the explosion reaches Earth, things unravel fast and there's no safe zone. The sun's energy would slam into the side of Earth that's facing it, instantly vaporizing much of the surface. Major cities like Los Angeles, Tokyo, and Sydney would be swallowed in flames almost immediately. Skyscrapers would collapse under the heat, concrete would melt. And it wouldn't stop there. The radiation doesn't politely knock, it bursts through the atmosphere, stripping away everything that makes life possible. Within seconds, forests, lakes, and entire towns would be torched. People in places like Mumbai, Cairo, and Rio de Janeiro wouldn't even have time to react. Most would be gone before they realized anything had happened. Even places not directly facing the sun, like New York City or London, would only have a momentary delay before the destruction wrapped around the globe. This isn't like a slow-moving natural disaster, it's an all-out, full-sweep planetary breakdown. Heat from the sun's explosion would travel in waves, and the pressure would flatten everything in its path. Mountains would erode, rivers would boil, and nuclear plants would go critical as power systems fail one after another. No emergency plan, no warning system, and no global organization could respond fast enough, or at all. Roughly 30 minutes in, the temperature across the planet would already be dropping. Not because things are calming down, but because the sun, our only natural heat source, is gone. In places like Canada, Scandinavia, and the Russian tundra, freezing winds would kick in almost immediately. The atmosphere would still be thinning from the radiation blast, and without gravity holding it close, much of it would start to bleed off into space. That means oxygen would become scarce fast. By the 1 hour mark, the sky would be pitch black. Clouds wouldn't form, rain would stop, and all natural cycles like wind, tides, and weather would start breaking down. Earth would be flying blind through space now. No light, no heat, no direction. People underground might still be alive, but only temporarily. Air would run out. Supplies wouldn't last, and the planet itself would already be shifting, cracking, and changing from the sheer force of everything that just hit it. From massive cities to small rural towns, from deserts to deep ocean floors, there would be no place left untouched. Earth's surface would look more like the moon than a living world. What was once full of color and life would be reduced to ash and silence. And yet, the worst part is, it's not even over. Because now Earth is alone in deep space with no sun to hold it and no path to follow. By now, Earth is completely cut off. The blast from the sun is behind it, but what's left is almost worse. A planet with no direction, no warmth, and no future. Without the sun's gravitational pull, Earth no longer has an anchor in space. It starts to drift, spinning slowly into the freezing black void. The temperature drops fast. Within a single day, the surface plunges far below freezing. Within a week, it would be colder than any natural condition ever recorded. Oceans begin to freeze from the top down. At first, it's just the surface that ices over, but by the second week, entire coastlines are locked in place. Sea life dies off quickly. Coral reefs shatter. Fish freeze in solid blocks of ice. Deep-sea creatures that once thrived in darkness now face a new kind of cold, one that doesn't allow for any survival at all. Even hydrothermal vents, which once supported strange life at the bottom of the ocean, start to shut down without surface heat or planetary balance. The atmosphere, now severely weakened by radiation and lacking sunlight, begins collapsing in on itself. Clouds no longer form. There is no rain, no weather, and no wind. The sky stays black. Snow falls only in the form of dry ice, frozen carbon dioxide. Land areas that didn't burn in the initial blast are now being buried under thick, choking frost. In places like Alaska, northern Canada, and Siberia, the ice expands faster than anything seen during the ice ages. Within a month, entire continents are covered in layers of ice thicker than skyscrapers. Power grids around the world, already shattered from the explosion, are now completely useless. Fuel freezes in storage tanks. Batteries drain and stop working. Every satellite in orbit is dark or drifting. Even underground bunkers, built to withstand nuclear war, struggle to keep the cold out. And worst of all, food production stops completely. No sunlight means no photosynthesis. Crops die, trees freeze, and animals begin to starve. Any human still alive is facing an extinction-level collapse of every system that once supported life. Communication is gone. There's no way to know who, if anyone, is still out there. Underground survivalists might last a little longer, living off canned food and artificial light, but with each passing day, oxygen runs thinner, and the cold pushes deeper into even the best-sealed shelters. Mental health would collapse alongside physical health. Without day or night, without a clock or calendar, time would feel meaningless. People wouldn't know if it was morning or midnight, and they'd never see the sky again. But even if someone did survive the first month, the question remains, what are they surviving for? Because with the sun gone, there is no rebuilding. No seasons will return, no rescue is coming. Earth has become a frozen rock adrift in deep space, and it's only getting colder. Months have passed since the sun exploded. Earth is no longer the planet it used to be. It's a silent, frozen world drifting through deep space with no source of light or energy. The temperature on the surface is now hundreds of degrees below zero, cold enough to freeze the atmosphere itself. Most gases that once made up our air, like nitrogen and oxygen, have condensed into frost, falling as strange snow onto what's left of cities, forests, and mountains. Every ocean is now a solid block of ice, stretching miles deep. Beneath the surface, pressure keeps some water in liquid form, but it's lifeless. The ecosystems that once made Earth unique are now just frozen layers of the past. The sky has not brightened once since the sun vanished. Earth's orbit is long gone, and the planet now moves randomly through interstellar space. Without the sun's pull, there is no day, no night, and no way to track time. Radiation from the explosion has altered the magnetic field. Compasses don't work, and the planet's internal systems, abyato, like plate tectonics and geothermal heat, are slowly shutting down. Even volcanoes have gone quiet, with magma chambers freezing over beneath layers of rock and ice. Structures that once stood tall, skyscrapers, bridges, monuments, are now buried or crumbled. Metal has become brittle. Concrete has cracked apart. The Eiffel Tower, the Great Wall, Times Square, all of it frozen in time. It looks more like an alien world than a place that ever held life. Even light from other stars barely reaches Earth anymore. The darkness is total. By the 1 year mark, any chance of human survival is gone. Food is long depleted, and even the most prepared bunkers have run out of heat, oxygen, or supplies. No sound exists outside of the cracking ice and shifting layers of snow. Earth is officially lifeless, not just on the surface, but in its core, its atmosphere, and its oceans. Fast forward hundreds of years, and Earth is just another frozen planet, so impossible to distinguish from a distant asteroid or icy moon. If an alien civilization ever found it, they might see traces of what was once here. Satellites frozen in orbit, spacecraft left abandoned, or the outlines of cities buried beneath centuries of frozen storms. But they would find no living thing. No voices, no signals, no warmth. Earth would be a tomb, and that's the harsh reality of this scenario. If the sun exploded without warning, it would not just end human civilization, it would erase everything. Every memory, every species, every sign of life, wiped out in darkness, with no chance of return. A world that once held over 8 billion people, thousands of cultures, and billions of years of evolution reduced to silence in under 1 year. Imagine looking up one morning and seeing a blinding light streak across the sky. Within seconds, the earth shakes beneath your feet, the air starts to heat up, and the sky glows like fire. That's what it might feel like if a 5-mile wide asteroid slammed into California. And in this case, there wouldn't be much warning. Even if we saw it coming a few days before, there would be almost nothing we could do to stop it. A 5-mile wide asteroid is about the size of Mount Everest, and when something that massive hits Earth at around 40,000 miles per hour, it's not just a local disaster, it's the kind of event that could change the planet. If it struck on land anywhere in California, the first thing to go would be the ground itself. The moment of impact would release energy equal to billions of tons of TNT. That's more powerful than every nuclear bomb ever made combined. The explosion would create a fireball miles wide, instantly vaporizing everything near the point of impact. Cities, highways, forests, gone in an instant. The temperature would rise so fast that people in buildings within hundreds of miles would be incinerated before they even heard the sound of the explosion. The impact would throw huge chunks of earth and rock miles into the sky, sending a massive shockwave rippling out in all directions. Buildings would collapse, power lines would be ripped down, water pipes would burst, everything in the surrounding area would be leveled. This wave would move so fast and hit so hard it would be like a hurricane, an earthquake, and a volcanic eruption all rolled into one, but worse. If it hit near Los Angeles, the city wouldn't just be destroyed, it would be completely erased. Right after the impact, a massive crater would form, likely over 50 miles wide and several miles deep. The surrounding landscape would be reshaped forever, and the debris, blasted into the sky, would block out the sun across much of the western United States. Fires would break out for hundreds of miles, burning uncontrollably as emergency systems collapse and response crews are completely overwhelmed or wiped out themselves. But the destruction wouldn't stop there. The energy from the impact would trigger massive earthquakes across the western part of the country. The San Andreas Fault would likely rupture in multiple places, and new fault lines might even open. The shaking would be felt across state lines, toppling buildings in places as far away as Arizona and Nevada. Tsunamis would also be triggered, crashing into nearby coastlines. If the asteroid hit even partially in the ocean near California, the waves would be hundreds of feet tall, slamming into the shore within minutes. This is just the beginning of what would follow. The first few minutes alone would be unlike anything humanity has ever seen. And for the people in California and the nearby regions, Survival would depend entirely on distance and luck. Now, the wave of destruction begins to spread across the map. Let's look at what happens next. Within the first hour after impact, the destruction would keep spreading far beyond California. Massive shock waves would roll across the western United States, toppling buildings as far as Salt Lake City, shaking the ground in Denver, and breaking windows in cities over 1,000 miles away. Roads and highways would be torn apart, bridges would collapse, and power grids would fail. Millions of people would be cut off from help, with cell towers down and communication systems overloaded or completely destroyed. The western skies would be filled with thick black smoke, ash and dust rising from thousands of fires. Some started by the heat of the blast, others by broken gas lines and collapsing electrical systems. Inland cities like Fresno, Bakersfield, and Sacramento would be reduced to rubble from the force of the shockwave alone. Buildings that weren't destroyed instantly would soon be brought down by aftershocks and spreading fires. Hospitals, police stations, and emergency services would either be gone or overwhelmed. Survivors would be scrambling to find clean air, shelter, and water. With debris covering the roads and the entire region in chaos, evacuation would be nearly impossible. Planes wouldn't be able to fly through the ash-filled skies, and helicopters could only reach a limited few before running out of fuel or being grounded by dangerous winds. As the blast zone widens, coastal cities like San Diego, San Francisco, and even parts of Seattle would be hit by massive tsunamis if the asteroid struck near the Pacific Ocean. These waves could reach heights of several hundred feet, flooding entire cities and washing away ports, airports, and residential areas. The salt water would flood deep inland, leaving behind toxic sludge and wreckage. Ships out at sea would either be capsized or lifted and hurled onto land by the force of the water. Entire neighborhoods would be swept away like driftwood. Meanwhile, the skies would darken across the entire continent. The asteroid would throw up millions of tons of dust and ash into the atmosphere, carried by the upper-level winds across the country. Places as far as Texas and even the East Coast would soon see ash falling from the sky like dirty snow. The sun would grow dim and temperatures would begin to drop, especially at night. People would be forced indoors, not just because of the danger, but because the air would be filled with ash particles that could clog lungs and poison water sources. By the end of the first day, tens of millions of people across the western half of the country would either be injured, displaced, or missing. Emergency broadcasts would play on repeat if they were still functioning, warning people to stay inside, wear masks, and avoid contaminated water. The US government and military would begin mobilizing, but the scale of the disaster would be beyond anything ever prepared for. Entire states would essentially be cut off, operating without fuel, electricity, or any connection to the outside world. And the worst part, this was still only the beginning. In the next part, we'll look at what happens over the next week and month, how far the damage spreads, which cities survive, and what the world starts to look like as the ash settles. Over the next few days, the damage would grow even worse as the full effects of the asteroid hit start to unfold. California, once home to nearly 40 million people, would now be unrecognizable. Entire city maps would be useless. Craters, collapsed highways, and flooded coastlines would erase any familiar landmarks. Survivors in Central and Southern California would have no electricity, no clean water, and very little access to food. The government would try to deliver emergency aid, but most airports would be destroyed, and the skies would be too dangerous for regular air traffic. Military cargo planes and helicopters would be forced to land in makeshift zones far outside the impact area. Beyond California, neighboring states like Nevada, Arizona, and Oregon would begin to feel secondary effects. Hospitals in cities like Phoenix, Las Vegas, and Portland would be overwhelmed as evacuees flood in, many suffering from burns, broken bones, and lung damage from breathing ash. Grocery store shelves would empty in hours, gas stations would run dry, and traffic out of the west would clog every major road. Entire communities would set up camps in parking lots, schools, or open fields just to have somewhere to sleep. Cities once thought to be safe would struggle under the weight of refugees and the collapse of basic systems. Meanwhile, the skies would continue to grow darker. The dust and ash pushed into the upper atmosphere by the asteroid would start to block sunlight across much of the western hemisphere. By the end of the first week, daytime would look like evening in many places. Crops would begin to die from lack of sunlight, and temperatures would drop noticeably. In California's Central Valley, where much of America's produce is grown, farms would be buried under layers of soot. The food supply chain, already fragile, would begin to break down. The effects would stretch across the country with prices rising and panic growing. Wildlife across North America would be thrown into chaos. Forests near the Rockies and along the west coast would burn uncontrollably, releasing more smoke into the atmosphere. Rivers and lakes would become clogged with debris and polluted from chemical runoff and dead animals. Birds would fall from the sky, confused by the lack of light, while fish die-offs would begin in both saltwater and freshwater systems. The sound of sirens, distant explosions, and silence where bustling cities once stood would be all that remained in many parts of the western United States. By the end of the first month, millions of people would still be unaccounted for, and entire regions would be labeled as unreachable. National and international aid would begin pouring in, but even the rest of the world would start to feel the ripple effects. Trade routes through California's major ports would be destroyed, stock markets would spiral, and the rest of the planet would watch and wait, wondering how bad the long-term consequences could really get. In the final part, we'll take a look at what life could look like 1 year after the impact, how the world adapts, what's left of the West Coast, and the lasting scars this event would leave on the planet. 1 year after the 5-mile-wide asteroid hit California, the world would be in a completely different place. The physical damage in California would still be beyond repair. Cities like Los Angeles, San Diego, and Sacramento would no longer exist in any recognizable form. What was once dense urban sprawl would now be a mixture of dry craters, twisted metal, collapsed concrete, and growing vegetation trying to reclaim the ruins. The crater itself, several miles wide and hundreds of feet deep, would be filled with stagnant water surrounded by the skeletal remains of highways and buildings. It would become a dead zone, not just from the impact, but from radiation and lingering atmospheric poisons kicked up during the explosion. For those who had survived, life would be about survival, not rebuilding. Makeshift towns would rise in the outskirts of the country, formed from shipping containers, scrap metal, and salvaged supplies. Most survivors would live without electricity, plumbing, or regular medical care. Diseases would spread faster in overcrowded shelters, and clean water would still be a daily struggle. Many would have moved to the east, trying to escape the choking air and find stability, but the entire country would be facing its own set of problems by then. The rest of the United States would now be dealing with a completely shifted economy. With California's agricultural centers gone, there would be a long-term food shortage. Farms in the Midwest and Southeast would try to keep up, but the loss of the Central Valley alone would have driven produce prices through the roof. Gas and oil would become even harder to transport, with so much of the West Coast shipping infrastructure destroyed. Unemployment would skyrocket, whole industries tied to the tech world, entertainment and trade would disappear overnight. The economic weight of rebuilding just a fraction of what was lost would be unlike anything the country had ever faced. The atmosphere itself would still be unstable. With so much ash and debris pushed into the sky, weather patterns would shift dramatically, global temperatures would drop. What scientists call an impact winter would settle in. Crops around the world would suffer, not just in the US, but across Europe, Asia, and parts of Africa. The sky would remain tinted in shades of gray, with red sunsets and dim mornings becoming the new normal. Climates would change rapidly, causing storms in places that rarely experienced them and drying out areas that used to be lush. But even with all this destruction, the world would try to move forward. People would form new governments in damaged regions. Aid from around the globe would help keep some areas stable. Scientists would spend years studying the crater, the asteroid fragments, and the effects on Earth's climate. And slowly the global conversation would shift from shock to survival, then to prevention. It would become clear that space isn't just vast and empty, it's filled with potential threats. And after witnessing what a single rock 5 miles wide could do, no one would ever look at the sky the same way again. It starts like any other stormy afternoon, but this time, it doesn't end. A single EF5 tornado touches down in a remote field in Kansas, tearing through everything in its path. The wind speeds are over 300 miles per hour. That alone is terrifying. But the worst part is, the next day, another EF5 forms. Then another the next day. Then dozens. Within 1 week, it's clear this isn't just a freak weather event, it's the beginning of something new. Something we've never seen before, a global, never-ending tornado outbreak with massive EF5 twisters spawning every single day across every continent. At first, it seems impossible. The kind of atmospheric energy needed to support that many EF5s day after day would mean the Earth's weather system has been completely rewritten. Maybe it started with a sudden, extreme warming of the oceans, triggering supercharged instability in the lower atmosphere. Or maybe some shift in the jet stream locked the world into a permanent storm cycle. Either way, every major tornado alley in the world becomes active. The United States, especially in the Central Plains, gets hit first and hardest. Within days, towns in Oklahoma, Kansas, Nebraska, and Texas are shredded. People don't have time to recover because each day brings more storms. Then Europe gets hit. Tornadoes tear through Germany, the Netherlands, and parts of France, places where tornadoes are rare and buildings aren't built to handle winds stronger than a normal storm. In Asia, huge twisters begin to strike India, China, and even parts of Japan. Massive cities start preparing for tornadoes every single day. It's no longer just a weather emergency, it's survival. Meteorologists are overwhelmed, storm warnings are sent out constantly, but even the best technology can't keep up with the number of funnels touching down. In just the first 10 days, more than 200 EF5 tornadoes strike worldwide. By the second week, there are no safe zones left. The tornadoes are no longer just hitting known hotspots. They're forming in places that have never seen them before. One touches down in the heart of Rio de Janeiro, another rips through the outskirts of Rome. A funnel carves through the dense neighborhoods of Manila, while a mile-wide twister levels parts of Lagos, Nigeria. The tornadoes don't follow any usual seasonal patterns anymore. They strike morning, afternoon, and night, regardless of location. For the first time in history, Antarctica is hit with its own terrifying vortex, caused by bizarre warming that throws the continent's usual climate into chaos. The laws of nature have changed, and the atmosphere is no longer predictable. Cities can't recover fast enough. In the United States, Denver is flattened, then St. Louis, then parts of Chicago. Every time one area is hit, emergency services rush in, only for another tornado to strike the exact same region the next day. Disaster response teams start running out of supplies. Power grids are crushed under the strain. Whole regions go dark for days, then weeks. In India, twisters strike the outskirts of New Delhi and sweep toward villages already struggling with infrastructure issues. In Australia, Sydney is caught completely off guard as an EF5 moves inland from the coast and rips through suburbs in minutes. By day 30, over 1,000 EF5 tornadoes have been recorded across the globe. Entire countries are forced to declare indefinite states of emergency. Military units are deployed not to fight an enemy, but to help evacuate millions of people away from zones of constant danger. But the problem is, no place is out of reach. Mountain towns, deserts, islands, nothing is spared. People begin fleeing their homes, not just because they're destroyed, but because they've lost trust that the ground beneath them can ever be safe again. Weather forecasting becomes nearly impossible. New tornadoes form in unpredictable places, sometimes multiple at once. The skies look darker every day, with massive rotating supercells blocking out sunlight in huge parts of the world. Some tornadoes now last for over an hour, traveling more than 100 miles before dissipating. Others spin up suddenly in cities and vanish after 10 minutes, leaving behind entire blocks of nothing but rubble. No one sleeps well anymore. Families take turns staying awake at night, listening for sirens, watching the skies, waiting for the next monster to drop from the clouds. And the worst part? There's no end in sight. After 2 months of daily EF5 tornadoes, the world starts to feel unrecognizable. Landscapes that once held cities, forests, and farmland are now wide scars of dirt and twisted wreckage. The tornadoes aren't just destroying buildings, they're erasing the environment. Forests that took centuries to grow are shredded in seconds. Entire ecosystems are crushed. Rivers change course from the damage, and lakes become filled with debris. In places like the Amazon and Southeast Asia, the destruction of dense tree cover leads to dangerous erosion. Animals are fleeing in all directions, but they have nowhere to go. The skies are filled with birds flying endlessly, confused and panicked, as their habitats are destroyed over and over again. In the United Kingdom, a tornado touches down in central London, leaving the historic city nearly unrecognizable. Buckingham Palace is reduced to rubble. The Eiffel Tower in Paris is torn apart by violent winds. Cultural landmarks, some hundreds of years old, vanish in a matter of minutes. Asia sees destruction unlike anything it has ever experienced. Tokyo is struck multiple times in a single week. In China, Shanghai and Beijing take direct hits just days apart. Each EF5 leaves behind damage that would take years to clean, if there were still time or resources left to do so. The Middle East doesn't escape either. In Saudi Arabia, twisters form over the desert and roll across oil fields, disrupting production and sparking massive fires that rage uncontrollably. In Egypt, a tornado twists through Cairo, toppling buildings and scattering centuries-old ruins. Africa's plains become dangerous paths for these storms, and refugee camps in places like Sudan and Ethiopia are devastated with little warning. Food becomes one of the biggest concerns. Crops are torn out of the ground before they can grow. Farms that once produced thousands of tons of wheat, rice, or corn are wiped clean. Livestock are gone, killed, scattered, or lost in the chaos. With supply chains broken and transportation systems destroyed, people are left with dwindling food stores. In some regions, clean water becomes just as scarce. Tornadoes rip through treatment facilities, spill sewage into rivers, and make it dangerous to even gather rainwater. Communication becomes harder every day. Satellites start malfunctioning as supercells grow higher into the atmosphere and lightning becomes constant. Cell towers are destroyed faster than they can be replaced. Power outages stretch into months, entire regions fall silent. People try to send out messages using radios and handwritten notes, hoping anyone is still out there. In some areas, tornadoes strike the same towns every few days, turning them into permanent danger zones. There's a growing sense that the planet itself has turned hostile. But people keep moving. Survivors travel by foot, searching for places that haven't been hit yet. They try to build underground shelters, dig out basements, or live in caves, anything to stay out of the sky's reach, but no one knows how long they can do this. Even the ground starts to feel temporary. The storm has become a global event and it shows no signs of slowing down. By the time a full year has passed, with daily EF5 tornadoes hitting the planet, the world has been fundamentally changed in ways no one could have imagined. Entire cities are gone, replaced by vast fields of rubble and twisted metal. Some of the largest metropolitan areas, including New York, Los Angeles, Mumbai, and Sao Paulo, have been struck repeatedly, leaving nothing but shattered foundations. The population has dropped dramatically as millions have either perished or fled to areas considered safer, although such places are now rare and shrinking. With most infrastructure destroyed, society as we know it has collapsed. Roads are impassable from debris and fallen trees. Airports and seaports have been obliterated, cutting off global trade and aid efforts. Hospitals are overwhelmed or destroyed, leaving the injured with little to no medical care. Governments struggle to coordinate any response, and many have dissolved into chaos. Communication systems are almost entirely offline, meaning coordination between regions is nearly impossible. In this new world, the constant threat of destruction haunts every moment. People have adapted by creating underground communities or hiding in natural caves, but even these places are not always safe. Tornadoes can cause flooding in tunnels or block escape routes with fallen debris. The weather remains erratic and extreme, with supercell storms forming continuously, fueled by the planet's unstable atmosphere. While the immediate destruction is horrifying, the long-term environmental effects make the situation even worse. Massive dust clouds thrown into the air block sunlight for months at a time, dropping temperatures in some places by several degrees. This nuclear winter effect makes growing food nearly impossible in many regions. Forests that once helped regulate the climate are gone, and soil erosion worsens with every storm. Freshwater supplies are contaminated or drained, leading to widespread shortages. And as this disaster drags on, the question shifts from survival of cities to survival of humanity. Food scarcity, lack of clean water, and exposure to harsh conditions push populations to the brink. Starvation and disease become widespread. The few remaining governments are unable to provide relief, and large-scale migration leads to conflicts over limited resources. The fabric of civilization starts to unravel. By the end of this terrifying year, the world has changed beyond recognition. The constant barrage of EF5 tornadoes has not only wiped out millions of lives, but has shattered ecosystems, crippled the planet's ability to recover, and destroyed nearly all systems humans rely on. The future looks uncertain, with humanity hanging by a thread, fighting against the forces of nature, unleashed in a never-ending storm. This nightmare scenario shows just how fragile life on Earth is, and how quickly everything could be lost if the weather went completely out of control. Weather control has been a dream and a mystery for humans for a very long time. Imagine being able to make it rain when crops need water, or stopping a big storm before it causes damage. It sounds like something out of a sci-fi movie, but with how fast technology is growing, it's not crazy to think we might actually get there someday. If humans learned how to control the weather, it could change everything about how we live on this planet. For farmers, it could mean ending droughts by bringing rain exactly when it's needed, helping grow more food and feeding more people. For cities, it could mean less damage from hurricanes or floods because storms could be weakened or redirected. This kind of power could help protect lives and save money, but weather is not simple. It's made up of many parts working together: air, oceans, temperature, wind, and even the sun. All these things interact in ways we don't fully understand yet. So controlling the weather wouldn't be like flipping a switch. It would be more like trying to solve a giant puzzle where every piece affects the others. This means any change we make could cause effects far away or far in the future that we didn't expect. One big question is what exactly would happen if we started changing the weather on purpose. For example, if we caused rain to fall in one place, would another place lose its rain? Would making it sunny in one area cause a drought somewhere else? The Earth's climate system is connected across the whole globe, so messing with one part could cause big problems somewhere else. And then there's the danger of overusing this power. If humans got used to controlling the weather, they might start changing it for small reasons, like always having clear skies for outdoor events or cool temperatures on hot days. But every change in nature has a balance, and breaking that balance could lead to serious problems. For example, if we stop storms too much, it could stop important natural cycles that keep our environment healthy. So while the idea of controlling the weather sounds amazing, it's also scary to think about the possible dangers. It's a huge responsibility, and we would have to be very careful not to cause more harm than good. In the next part, we'll look at some ways scientists are already trying to influence the weather and what problems those efforts have faced. Even though fully controlling the weather is still a long way off, scientists have been experimenting with ways to influence it for decades. One of the oldest and most well-known methods is called cloud seeding. This technique tries to encourage rain or snow by adding tiny particles like silver iodide or dry ice into clouds. These particles help water droplets inside the clouds stick together and fall as precipitation. Cloud seeding has been used in different parts of the world since the mid-20th century. For example, during the drought in California in the 1970s, efforts were made to increase rainfall by cloud seeding. Some places have also tried it to reduce hail that can damage crops or buildings. While some reports say it helped, the results are mixed, and scientists still debate how effective it really is. Beyond cloud seeding, there are even bigger ideas called geoengineering projects. These involve changing the Earth's climate on a large scale to try and fix problems like global warming. One idea is to spray tiny particles high into the atmosphere to reflect some sunlight back into space, which could cool the planet a bit. This is sometimes called solar radiation management, but geoengineering brings up a lot of concerns. First, it's unclear what side effects could happen. Changing the amount of sunlight reaching Earth might cool some places, but cause droughts or floods in others. Also, if we relied on this to fight climate change, it might stop people from reducing pollution and greenhouse gases, which are the real cause of the problem. Another issue is who gets to decide when and how to use these technologies. Weather and climate affect the whole world. So if one country tries something and it causes problems in another, there could be serious conflicts. Imagine if a country caused rain to fall on its own farmland, but ended up causing droughts in a neighboring country. This could lead to political disputes or even fights. Scientists are also exploring new technologies that might improve how well we can predict the weather. Better forecasts could help us prepare for storms and avoid disasters without actually changing the weather itself. Using satellites, powerful computers, and better weather models, meteorologists are getting more accurate at knowing when and where extreme weather will happen. So, while cloud seeding and geoengineering show us some ways to influence the weather, they also teach us how tricky and risky this can be. The Earth's systems are delicate, and even small changes might create big problems we don't see coming. In the next part, we'll explore what could go wrong if weather control gets into the wrong hands, and what scary consequences might happen if things are pushed too far. One of the biggest worries about humans controlling the weather is what could happen if the technology falls into the wrong hands or is used without careful thought. Imagine if powerful weather control tools became weapons. Countries or groups might try to create storms, droughts, or floods to harm enemies or gain an advantage. This idea sounds like something from a thriller movie, but it's a real concern among scientists and governments. Weather warfare isn't new as a concept. In the 1960s, during the Vietnam War, the US military tried to use weather modification to extend the monsoon season, hoping to disrupt enemy supply routes. They used cloud seeding to cause heavy rains, but the full effects and consequences of those actions are still debated today. This shows how controlling weather, even on a small scale, can can be unpredictable and controversial. Another scary possibility is that controlling the weather might create new kinds of natural disasters. Because weather systems are so complicated, changing one thing could trigger others. For example, if we tried to prevent hurricanes by cooling ocean temperatures in one area, it might cause stronger storms somewhere else. Or stopping rain in one place could lead to deadly droughts and wildfires. Also, weather control might hurt natural ecosystems that depend on certain weather patterns. Many plants and animals have adapted over thousands of years to the local climate. Sudden or artificial changes could disrupt migration patterns, breeding seasons, and food availability. This could lead to loss of biodiversity and damage to the environment that might be hard or impossible to fix. There's also the chance that people could become too dependent on weather control technology. If we start relying on machines to fix everything, we might forget how to prepare for natural events or adapt to changing conditions. And if the technology breaks down or stops working for some reason, the sudden return to natural weather patterns could cause chaos and confusion. These risks show that controlling the weather isn't just about technology, it's also about ethics, responsibility, and global cooperation. Who decides when to change the weather? How do we make sure it's done fairly and safely? These questions don't have easy answers, but they are important to think about as we move closer to making weather control a reality. In the next part, we'll look at some of the exciting scientific progress being made today and what the future might really look like if humans do gain control over the weather. Despite all the risks and challenges, scientists and researchers are still pushing forward with new ideas and technologies that could help us better understand and maybe even control the weather one day. One area showing promise is improving how we predict weather events. With better data from satellites and supercomputers, weather forecasts are becoming more accurate and can warn us earlier about storms, heat waves, or heavy rainfall. This means we can prepare better and reduce damage even if we're not fully controlling the weather yet. There are also exciting experiments with new materials that might help with weather modification. For example, some scientists are studying how tiny particles could help clouds produce rain more reliably, or how smart drones could spread these particles more precisely. These efforts aim to make cloud seeding more effective and less harmful to the environment. Another interesting idea is using nature itself to help control local weather. Planting more forests or restoring wetlands can change how moisture moves through the air and help regulate temperature. These natural methods might not be as fast or flashy as machines, but they work with the environment rather than against it, making them safer in the long run. Looking ahead, the future of weather control will likely be a mix of technology and nature, combined with careful rules and global cooperation. Scientists warn that we have to move slowly and think carefully about every step, because once we start changing the weather on a big scale, it will be hard to undo. So, what would really happen if humans learn to control the weather? It could bring amazing benefits like ending droughts, protecting communities from storms, and helping farmers grow food better. But it could also lead to new dangers, conflicts, and damage to the environment if not handled responsibly. At the end of the day, weather control is one of those powerful tools that could change the world for better or worse. The future depends on how wisely we use it, how well we understand nature's delicate balance, and how much we work together as a global community. What do you think? Would you trust humans with the power to control the weather, or does it sound too risky? Drop your thoughts in the comments, and if you're curious about more cool science topics and ideas about the future, be sure to check out my other videos. What if a powerful blast from deep space suddenly wiped out life on Earth in just minutes? Imagine a gamma ray burst, or GRB, blasting our planet with intense radiation so strong it could end humanity almost instantly. These bursts are the brightest explosions in the universe, releasing more energy in seconds than our sun will produce in its entire 10 billion year lifetime. While they usually happen millions or even billions of light years away, if one were to aim directly at Earth from a nearby star, the consequences would be devastating. A gamma ray burst happens when a massive star collapses or when two neutron stars collide, shooting beams of deadly gamma radiation across the cosmos. These beams travel at the speed of light, so we wouldn't have any warning. The burst would slam into our atmosphere, stripping away the ozone layer that protects us from harmful ultraviolet rays from the sun. Without this shield, radiation levels on Earth's surface would skyrocket, causing widespread damage to living cells and leading to almost immediate mass extinction. The initial flash alone would be powerful enough to fry everything exposed on the planet's surface. This event is not just a bad day for humanity, It's an extinction-level disaster. The burst would destroy the delicate balance of our atmosphere, leading to a chain reaction of effects. Intense radiation would break apart nitrogen and oxygen molecules, producing dangerous nitrogen oxides that would further eat away at the ozone. As a result, Earth's surface would be bombarded by lethal UV rays for years to come. The sun's protective blanket would be gone, leaving all plants, animals, and humans vulnerable. In just minutes, the gamma ray burst would deliver a lethal blow to life on Earth. But the fallout wouldn't stop there. This cosmic explosion would trigger wildfires across continents, as the intense radiation ignites forests and grasslands. The heat alone could be enough to start uncontrollable blazes, turning vast areas into ash. At the same time, the sudden collapse of the ozone layer would cause global temperatures to fluctuate wildly. With no protection from the sun's rays, parts of the planet would scorch while others suffer from extreme weather shifts. The scale of destruction from a gamma ray burst hitting Earth is hard to fully grasp, but it's safe to say it would be one of the most catastrophic events our planet could ever face. This isn't just science fiction. Astronomers have found evidence of past gamma ray bursts in our galaxy that may have impacted life millions of years ago. Understanding what would happen helps us appreciate how fragile our existence is and how cosmic forces beyond our control could change everything in an instant. The moment a gamma ray burst hits Earth, the damage would spread fast and wide, wiping out entire cities and regions almost instantly. The initial blast of gamma radiation would be so powerful it could penetrate buildings and fry electronic systems, shutting down all technology in its path. Major cities closest to the burst's impact zone would face near total destruction. The radiation would cause electrical storms and electromagnetic pulses that knock out power grids worldwide, throwing humanity into darkness and chaos. Beyond the immediate destruction, the intense radiation would trigger fires across forests, grasslands, and urban areas alike. These fires would burn uncontrollably for days, fueled by the dry conditions caused by the burst disruption of Earth's atmosphere. The thick smoke would blot out the sun, creating a dark, smoky sky that could last for months. This nuclear winter effect would cause temperatures to drop sharply, adding to the planet's suffering and making survival even harder. On a timeline, the first few minutes after the burst would be the deadliest. Radiation levels would spike, killing any living things exposed on the surface almost instantly. Within hours, wildfires would rage and spread, destroying homes, habitats, and food sources. In the days that follow, the ozone layer would remain severely damaged, allowing lethal ultraviolet radiation from the sun to reach Earth's surface without any protection. This would cause widespread radiation sickness and increase cancer rates among survivors, if there were any. As the weeks passed, the damage to the atmosphere would cause unpredictable weather patterns. Violent storms, extreme temperature swings, and droughts would become common. Crops would fail due to lack of sunlight and poor growing conditions, leading to food shortages around the world. The disruption to ecosystems would ripple through the food chain, making it difficult for animal and plant species to survive. The destruction wouldn't be limited to any one country or continent. Gamma ray bursts don't care about borders. The entire planet would face the consequences, with cities on every continent suffering from fires, radiation, and infrastructure collapse. The loss of communication and transportation networks would make organized rescue or relief efforts nearly impossible. Humanity's ability to respond to the disaster would be crippled from the start, making survival a desperate fight against overwhelming odds. In short, a gamma ray burst hitting Earth wouldn't just harm one area or cause localized damage. It would be a global catastrophe, destroying cities, causing long-lasting environmental damage, and pushing human civilization to the brink of collapse in a matter of minutes to days. The full scale of destruction would be unlike anything in recorded history, marking a terrifying end for the world as we know it. After the initial devastation, the longer-term effects of a gamma ray burst hitting Earth would become even more devastating. One of the biggest problems would be how the burst would strip away a large part of our ozone layer. This layer normally protects us from the sun's harmful ultraviolet rays, but after the burst, it would be badly damaged and take years, possibly decades, to recover. Without this protection, intense UV radiation would reach the surface, causing severe harm to any plants, animals, and humans still alive. Skin cancer rates would soar and many species would struggle to survive. The burst's impact would also cause a collapse of the food chain. With the skies darkened by dust and smoke, plants would not get enough sunlight to grow properly. Crops would fail across the globe, leading to widespread famine. Animals that rely on plants or smaller animals for food would also suffer, disrupting ecosystems everywhere. This chain reaction would make survival even harder for humans, who depend on these natural resources for food and clean air. Another serious consequence would be the permanent damage to Earth's atmosphere and climate. The particles released into the air would cause extreme weather changes. Some areas might experience severe droughts, while others could face massive storms and flooding. These chaotic weather patterns would make farming and living conditions extremely difficult. Cities already weakened by the burst's initial impact would struggle to cope with these new challenges, increasing the risk of societal collapse. The damage to technology and infrastructure would also play a huge role in how this disaster unfolds. Power grids and communication systems would remain offline for months or even years. Without electricity, hospitals, water treatment plants, and food storage facilities would fail, making it nearly impossible to provide basic needs. Transportation systems would also be disrupted, cutting off supplies and slowing down any relief efforts. This isolation would make recovery slow and painful. Finally, the psychological and social effects on survivors would be profound. The sudden loss of loved ones, homes, and familiar life combined with the harsh conditions would lead to widespread despair and chaos. Governments and organizations would struggle to maintain order, and many people would face an uncertain and dangerous future. The gamma ray burst wouldn't just destroy the Earth physically, it would tear apart human society itself, creating a crisis that would last for generations. As the years pass after a gamma ray burst hits Earth, the planet would face a long, slow road to recovery, if recovery is even possible on a large scale. The damage to our atmosphere and ecosystems would linger for decades, with the ozone layer taking a very long time to rebuild. During this period, life on Earth would be forced to adapt to harsher conditions, including much higher levels of ultraviolet radiation. Many species would go extinct, while others might evolve to survive in this new, more dangerous environment. Human society, if it still exists in any organized form, would have to fundamentally change. Cities and infrastructure destroyed or damaged by the initial burst and the following environmental chaos would remain in ruins for many years. Food and clean water shortages would continue to be a major problem, pushing survivors toward finding new ways to farm and gather resources, often in small, isolated communities. Technology would have to be rebuilt from the ground up, but with limited resources and knowledge, progress would be slow. The psychological scars left on humanity would run deep. Generations born after the event would grow up knowing only hardship, loss, and struggle for survival. The memories of the gamma ray burst and its destruction would become a part of history, told as a warning about the fragility of life on Earth. The burst would serve as a reminder of how vulnerable our planet really is to forces beyond our control in space. In the end, a gamma ray burst hitting Earth is one of the most extreme threats to life imaginable. It could wipe out nearly all living things in a matter of minutes and leave the planet a much different place for hundreds or thousands of years. While the chance of this happening is low, the scale of devastation it could cause makes it one of the most terrifying what-if scenarios for humanity's future. Understanding this helps remind us how precious and fragile life is and why exploring space and studying cosmic events is so important to help protect our home. If a supervolcano ever erupted off the coast of Oregon, the first signs wouldn't be an explosion right away. It would probably start with strange activity deep below the ocean floor. Scientists would notice small earthquakes happening more often than usual, along with a rising dome of lava slowly pushing up the seafloor. That part of the Pacific Ocean, near the Juan de Fuca Ridge, is already geologically active. It sits right on the edge of the Cascadia subduction zone, where two tectonic plates are constantly grinding against each other. So the warning signs might look like normal volcanic or earthquake activity at first. This would be different, more intense, and happening all at once. The water temperature around the area might start rising. Steam vents and plumes of gas would rise up from the ocean floor, and the water could turn cloudy or discolored. Fish and marine animals might start fleeing the area, reacting to sudden changes in pressure, temperature, and chemicals. Scientists monitoring the area would detect rising levels of sulfur dioxide and carbon dioxide. That's when alarm bells would really go off. These are the types of gases released when magma is building up close to the surface, and a massive amount of it could mean a supervolcano is getting ready to blow. News reports would start coming in. warning people along the Oregon and Northern California coasts. Emergency services would begin preparing for a possible eruption. The U.S. Geological Survey and NOAA would issue alerts and begin tracking everything closely. People living along the coast might be told to evacuate even though the volcano is still underwater. That's because a supervolcano under the sea doesn't just erupt with lava, it can trigger tsunamis, massive clouds of ash, and poisonous gases. Then it would happen. If the volcano erupted all at once, the explosion would be unlike anything anyone has ever seen. The force would send a huge plume of ash, gas, and debris shooting up from the ocean. Since water would instantly flash into steam when it hit the magma, the explosion could be even more violent than one on land. The blast would destroy everything within dozens of miles, both under the sea and in the air. A massive crater would be left on the ocean floor. The eruption would also displace a massive amount of seawater, likely triggering a powerful tsunami almost immediately. That wave would start racing across the ocean in every direction. Coastal towns along Oregon, Washington, and Northern California would only have minutes to react. Even places as far away as Alaska and Hawaii could feel the effects. The ash cloud, meanwhile, would begin spreading high into the atmosphere, carried by strong winds. Planes would be grounded, skies would go dark, and breathing outside could become dangerous. That would just be the beginning. In the next part, we'll look at what happens in the hours and days after the eruption and how it could affect not just the West Coast, but the entire country. In the hours right after the eruption, the West Coast would be in chaos. The tsunami triggered by the explosion would hit the Oregon coastline first. Towns like Newport, Lincoln City, and Coos Bay would be among the first to get hit. With only minutes of warning, many people wouldn't have time to get to higher ground. Waves as tall as buildings would crash into the shore, wiping out homes, roads, and anything in their path. The force of the water would drag debris miles inland, turning once peaceful neighborhoods into wreckage. Farther down the coast, places in Northern California, like Crescent City and Eureka, would also feel the full power of the wave. Washington's coast wouldn't be spared either. The water would slam into the ports, flood highways, and knock out power. Emergency systems would be overwhelmed. First responders would be racing to help, but the damage would make many areas impossible to reach. Entire stretches of coastline might become completely unrecognizable in just a few hours. At the same time, the ash cloud from the eruption would begin drifting across the sky. Depending on wind direction, it could move inland fast. Ash is not like soft snow. It's more like tiny pieces of glass. When it settles, it clogs engines, shuts down power plants, and makes it hard to breathe. Towns as far inland as Eugene, Bend, and even Boise could find themselves covered in a gray, suffocating layer. Breathing outside without a mask would become dangerous, especially for kids, the elderly, or anyone with asthma or other lung issues. Flights across the Pacific Northwest would be canceled. Airports from Portland to San Francisco would shut down, and skies across the region would be eerily quiet. Ash in the upper atmosphere can stall jet engines, and no one would take the risk of flying through it. Major highways would be buried in ash and debris, making ground travel nearly impossible in some areas. The power grid would be in serious trouble too. Ashfall can cause transformers to short out and power lines to snap. Some cities could lose power for days or even weeks. With communication lines down, it would become harder for emergency crews to coordinate. People in the worst hit areas might be cut off completely, unable to call for help or even find out what's happening beyond their own street. Food and clean water would start becoming scarce fast. Grocery stores wouldn't be able to restock, and ash would contaminate rivers and reservoirs. Cities would urge people to boil water before drinking it if they still had power. Hospitals would quickly fill up with people suffering from injuries, breathing problems, or exposure to the elements. In some places, makeshift shelters would have to be set up to house survivors. And all of this would be happening just in the first day or two. If the supervolcano off the coast of Oregon were to erupt with full force, one of the most dangerous things to come right after the blast would be the wave. Not just a regular wave, but a giant, unstoppable wall of water. We're talking about a tsunami that could be hundreds of feet high, moving at the speed of a jetliner. When that much of the ocean floor gets torn open and shoved around in such a short amount of time, the ocean has nowhere else to go. It rises, and it crashes toward the land with unbelievable power. This wave wouldn't just hit Oregon, it would slam into the entire West Coast. Places like Crescent City, Eureka, and Coos Bay would be among the first to feel it. Cities like San Francisco and Seattle wouldn't be far behind, Depending on where the eruption started and how the seafloor moved, some places might only get minutes of warning. Others could have up to an hour, but when the wave came, it would come fast, and it would come hard. Entire coastal towns could be wiped out in one single strike. Buildings, roads, cars, and even people would be swept away. The tsunami wouldn't be one clean wave and then it's over either. There could be multiple waves coming in and out for hours. The first one might weaken buildings. The second or third could finish them off. Even places several miles inland would not be safe, especially in lower lying areas where the water could push its way through rivers and bays. Ports and harbors would be destroyed. Fishing boats, container ships, and ferries would be tossed around like toys. Any oil tankers nearby could be damaged, causing leaks into the ocean. That would create a whole new environmental disaster on top of the eruption. Emergency services would be stretched too thin. Even if rescue teams were prepared for a normal tsunami, this wouldn't be normal. A supervolcano-triggered wave is on another level. Coastal highways would vanish. Power lines would go down. Communication would be lost in many areas. People would be separated from their families. Cell towers near the coast would be gone in an instant, and that would make it even harder for people to know what was coming next. Meanwhile, people farther inland would be watching the news, trying to understand what was going on. Shelters would fill up quickly, evacuations would have to move even faster. Airports in cities like Portland and Sacramento would be packed with people trying to get out, but many flights would still be grounded because of the ash in the air. That means the roads would be jammed, gas stations would run dry, and tempers would rise. People would be scared, confused, and desperate, and this isn't just about the United States. A wave that big, starting in the Pacific, wouldn't stop at one country's border. After it hit the west coast, it would keep going. Hours later, it could reach Hawaii. Eventually, it might even make it as far as Japan, the Philippines, and parts of Australia. It would lose some power the farther it traveled, but it would still be strong enough to do damage. In the middle of all this, the volcano could still be active. That's what makes the situation so scary. The eruption, the ash, the fires, the wave, none of it means it's over. In the final part, we'll talk about what the world could look like after all this. Could life return to normal, or would things be changed forever? In the weeks and months after this supervolcano erupted off the coast of Oregon, the world would be a very different place. The skies across large parts of the globe would still be filled with ash. That thick gray dust would block out sunlight, drop temperatures, and make it hard to breathe in some areas. Crops would fail, especially in the northern hemisphere. Farmers in places like California, Canada, and even parts of Europe might see their entire harvest ruined by cold, dark skies and falling ash. This sudden change in the climate is sometimes called a volcanic winter. It has happened before, thousands of years ago, when other supervolcanoes erupted. Back then, global temperatures dropped by several degrees for months or even years. If this were to happen today, food would quickly become a global crisis. Grocery store shelves would empty fast. Countries that rely on imported food would be hit the hardest. That includes places like Japan, the United Kingdom, and many island nations. With food supplies down and power grids damaged from the eruption, millions of people could find themselves in the dark and hungry. Some might be forced to move, creating huge waves of climate refugees. Major cities like Los Angeles, San Francisco, and Seattle might lose power for weeks. Clean drinking water would also become harder to find, especially if local water sources were contaminated with ash or debris. The economic fallout would be massive. Entire industries could collapse, especially those that rely on travel, farming, or shipping. Global stock markets would crash. Factories might shut down because they could not get the parts or materials they need. Businesses in every corner of the world would feel the impact, even if they were nowhere near the blast zone. The damage to the ocean would also have long-term effects. The massive tsunami would have pushed salt water deep into freshwater rivers and destroyed coral reefs and underwater ecosystems. Fish populations would take years to bounce back. And if oil tankers or chemical plants near the coast had leaked during the disaster, marine life might never fully recover. At the same time, governments around the world would be trying to figure out how to respond. Emergency funds would run out quickly. The United Nations might step in, sending aid to the hardest hit areas. Countries might have to work together more closely than ever before, just to make sure people could eat, stay warm, and survive the next winter. There would also be deep emotional scars. Millions of people would lose homes, loved ones, and any sense of normal life. Schools would close for months, maybe longer. Hospitals in some areas might shut down from lack of supplies or electricity. Mental health problems like anxiety, fear, and grief would rise in every community touched by the disaster. And even after the ash cleared and the skies brightened, the threat of more eruptions could still hang over everyone's heads. Scientists would continue to monitor the area closely, unsure if the worst was truly over. It might take decades for coastal towns to rebuild, if they are ever rebuilt at all. But even in all of that darkness, there would be signs of hope. People tend to come together in times of crisis. Volunteers would help rescue efforts, families would rebuild homes, communities would share food and supplies, and slowly, day by day, life could start to come back. Still, if a supervolcano ever erupts off the coast of Oregon, the world as we know it would never be the same again. The damage wouldn't just be about what was lost, but about how we learned to live in a world that suddenly became very different.